And let's do attendance. So far we've been talking about divine providence. I want to introduce kind of another one of those founding values today, and that is what our founders used to refer to as private virtue. It's a term we don't use anymore, and the closest thing we have to it would be like individual morality. We used to believe that we had a response, and I think today, still most of us think we should do the right thing, even when no one's looking. But we seem to be connected. We have that connection through our kind of religious upbringing, is where we kind of connect to that ideal. And it used to be that we thought we had a responsibility to live lives of private virtue. We had a responsibility towards our country to do that, not to our God or to our religion, I guess, in a roundabout way to our God. But let me just introduce this quote from Samuel Davies. So Samuel Davies was one of the three main preachers of the Great Awakening. You are familiar with the Second Great Awakening. It was a time around the 1820s when there was kind of an unusual excitement in the area of religion. That happened about 100 years before, in the 1730s, and that's just referred to as the Great Awakening. But he was one of probably the three main ministers who were involved in pushing forward that awakening. He is the mentor of our founding fathers. If we say, who of the founding fathers was the best orator, do you know who that would be? The most powerful orator of all the founders? Curious? I don't know. Patrick Henry. He was Patrick Henry's mentor. He learned his oratory style from this guy, Samuel Davies. In the very beginning of the French and Indian War, as we have heard already, war is going badly for the French and the Indians. So badly that the Virginia militia cannot meet their quotas for recruits. And that all changes almost overnight when Samuel Davies gives this sermon, which is entitled The Curse of Cowardice. It's where he lays out very expertly the argument that we have a responsibility to fight to defend our country. And at the time when I first read about this, I thought, how could a sermon like really change the minds of people to like on a large scale? And I thought, who's really paying attention in church anyway? But it turns out that when you had a good sermon in the day, you didn't just give it once. You kind of went around and gave it over and over again. And if printers got a hold of the text, they would print it with or without your permission, and sell it. That's incidentally is how Benjamin Franklin became wealthy enough to retire early. He retired quite young. It was printing religious tracts during the Great Awakening in in the early 1700s. Anyway, so he gives this sermon, and he focuses the sermon on Jeremiah chapter 48, verse 10, which reads, "Cursed be he that doeth the will of the Lord deceitfully, and cursed be he that keepeth back his sword from blood." He does an excellent job kind of laying out this argument, but he gets to the end, and he says this. He says, "Here I thought to have concluded, but I must take a few minutes more to ask this crowd, is there nothing that can be done by those of us who remain at home towards the defense of our country and to ensure the success of the expedition now in hand," referring to the war, the French Indian War. He says, "Shall we sin on still, Shall we sin on still impenitent and incorrigible? Shall we live as though we and our country were self-dependent and had nothing to do with the supreme ruler of the universe? Can an army of saints or of heroes defend an obnoxious people ripe for destruction from the righteous judgment of God?" And so he's making the connection for us here between private virtue, the responsibility that we have to live lives of individual morality, and divine providence. Because if we expect God to intervene and fight our battles, we have to be worthy to do it. And so we used to feel that we had a responsibility to choose the right because our country needed us to live that way. And it's kind of different than the way we feel about it now. Anyway, there we go. Samuel Davies would actually go on to become president of Princeton University. All right, we're recording. I think we're ready to get going. So today we're talking about loops. We'll be looking at several different loops. We've got a file to download that's got some data for us to work on here. So let's go ahead and get that file downloaded. What is it? Control J, I'm gonna show in folder. And I don't know if this is like universal now or if everyone's struggling with this, but just remember, anytime you download for this class a workbook, you're going to want to right click on it, go to properties and unblock it. So I think I've already unblocked it. So it used to say, unblock here. I unblocked it. And so now it's, it's going to be okay. Otherwise, it won't let me run any of the code that's in it. So let's just take a look and see what we've got going on here. But I think what we have here, this is a list of the FIPS codes for all of the states. So I don't know what FIPS stands for, but it's the way that we get census data kind of aggregated up from the county level. And so, each county has a particular code. And in fact, the way we aggregate it, each state has a code as well. So, here's a particular county in Alabama, Atagua, I don't know how to pronounce it, but it's 1001, Baldwin is 1003. It looks like they're all odd numbers. I'm not sure why that is. But then they're going to use the FIPS code 1000 to aggregate to all of Alabama. And so it's a way that the census uses for keeping track of data. I think I've got some code already built into here. Let's just see what code we have. So we've got this module web query, and we've already got like some code started here. So I think the idea here, we're going to introduce ourselves and kind of formally to all the different kinds of loops that we can do in VBA. So we'll be just kind of curious to see how this works. Now, let me just kind of point you at this web query module. So this web query module here is just where I've taken the code that normally gets generated when you make a web query and just written it so you can call the functionality to just create a web query directly. So you don't have to record yourself doing it and then modify it the way that we've done in past classes. But now we can just call directly, create web query, pass it a URL, pass it a destination where we want the results to go, and some other options. And we can just kind of reach out and request that. And it looks like already here in module 1, we've got a sub-procedure here called import county data. We just have to pass it a FIPS code, and it's going to bring that, it's going to use this create web query to put it onto a particular sheet. So looks like, we're going to add a worksheet. So we're declaring S as a worksheet. So similar to the things we looked at last time we were together, working with built-in objects, we are going to add a worksheet. So we're going to call the add method of the worksheets class in this workbook, and we're going to make a new worksheet, and we're going to capture that with the variable S, the object variable S. Now, let's just take a look at this right here. So we are passing a parameter to this add method, and we're telling it, where do we want to put this worksheet? We can either tell it to put it before a particular worksheet, or we can tell it to go after a particular worksheet. So which worksheet am I telling it to go after here? This is, I think all the things here we've kind of seen before, we haven't put them together this way. But where is that worksheet going to be created? Kind of another way to say would be, look at that part that I have highlighted, and let's say, which worksheet is it identifying? Because it's going to go after whatever worksheet is identified there. Go ahead.
Basically, give it your big list of worksheets, right? It's the same, like whatever the last one is, add it after that last one.
Very good. So here, what we're saying is that this is the collection of worksheets. And remember, we can identify an element of the collection of the worksheets, one of the worksheets in there, either by its name, we can put the name here in parentheses, that would identify it, or its ordinal position. And so by putting here, I'm saying, listen, however, I want to, tell me how many worksheets there are, give me the count of the worksheets. And so if that's, 7, then there are 7 worksheets, and I'm telling it to go after the 7th worksheet. So this sheet is going to be created at the very end of whatever worksheets we have. There's not many here. There's only one here to start with. And it looks like I even have like a little test procedure here that will call import county data, and it will pass it one of the FIPS codes there. So I'm just going to kind of run this, and hopefully we'll actually import some data and put it onto a new sheet. And looks like we've got it here. It is no coincidence that it's Gov County, Kansas, the county that I am named after. So, you know, it's my favorite county. Labor force, the labor force, this is not in thousands, that's the labor force, 1,467 people. It's a small place. And we see that unemployment rates for time going forward from 2008. So we're coming down to July 2022, the most recent numbers. Oh, and these are probably, looks like they're projected. So we don't actually have the numbers in here for this. Okay. So any questions on kind of the setup, kind of what we have already going on in this workbook? How comfortable are you with the code that we've got here? Just kind of show me on a scale of 0 to 5. So kind of looking at what we have here, how comfortable are you with what we're looking at? I'm seeing 3, 3, 3, a lot of 3s. Okay, so some 2s. So is there anyone saying, hey, you know, we'd like to review this a little bit more before we move on and just kind of use this, or we're kind of ready to move on and kind of hope it comes along a little more? All right, let's go ahead and move on then. Okay, so there's a couple of things that we might want to do. Now, it could be that where we're headed in this is that we need to pull in like this most recent unemployment data for each one of our counties that we have here. And so let's go ahead and start off with making a loop that's going to kind of iterate across all of these. In fact, why don't we go ahead and build that right in this get data right here. So get data right now is only bringing in 1, but we'd like to put this in a loop, and we'd like to have this loop then iterate across all of our sheets over here on the counties sheet. So that's going to be our first step, is we're going to make a loop that will go across all of this data and bring it in. Should be pretty similar because we've done something similar to this, but we're going to look at a few new things in this example. So back to my code window, and let's look at this. So here's something that's new that I don't think we've talked about this yet. So there are 2 different names by which I can refer to a worksheet in my code. There is the name that is on the tab, so counties, right? So I could say, you know, worksheets. Let me just kind of do this in the immediate window. Worksheets, and then give it a name. I mean, I talk about the one that I want to see. I'm saying I want to print that, and I'm going to print I'm just going to print the name. Seems like a little strange thing to say, give me the sheet that has this name and tell me what the name is, but that's just to show that we can refer to it by its name. And so when I'm looking over here in my Project Explorer, you see if I can zoom in a bit on this. When I'm looking here in my Project Explorer, I can see here that counties in, you know, with a capital C, that is the name that appears on the tab. And so this is the syntax that I can use to refer to that directly. Now, the name to the left, the one that's not inside the parentheses, that's referred to as the code name. It's not like some kind of secret agent who has a code name or something. It's like the name that I can refer to it directly in code. And so I can also get at its name property by just saying its code name. Its code name is county. C-O-U-N-T-Y. I'm not sure why the screen is shifting while I'm typing. So county.name. So this is like the direct name of that worksheet. Here, this is the name that appears on the tab, and I can get at the object by using the worksheets collection to get there, or I can refer to that object directly by its name. And so that should give me the name of the worksheet as well. Okay, so that's the first thing that's kind of neat, is that I can change the name. In fact, we can change the name of it right here. I'm not going to change it, but if I select this sheet here, then I will see that over here in the properties, right here, the top one, name, I can change that right here. Now, it's been my experience that if we were to change this here in class, that would be immediately accessible to about 90% of you. And the other 10%, for some reason, would have to close the workbook and open it again before that name is actually read. And I don't know what the difference was. Maybe it was an older version of Excel that some of my students had. So I don't change the names like during examples in class, but this one happens to have it here already named. And so we're going to use that to refer to that particular sheet. All right, so what are, and let's just kind of do this in the way that we've done it before, but we'll talk about it a little more completely. So here inside of get data, then I'm going to declare a variable that I'm going to use to kind of keep track of where I am. So I'm just going to call this row, and I will dim this as a long integer. Now, how many different counties do we have here? How many different counties? So we're starting on row 2, we come down to row 3,274. So it sounds like here in our country, we've got something like 3,273 counties, at least that we're keeping track of this way. My guess is that's all the counties. And so if I'm going to have a variable to keep track of which row I'm currently thinking about, then what data types are available to me? Or what data type might not work? When I say data type, I could declare a variable to keep track of the row. So here I'm going to say dim row as, what would be a data type that I could put in here that would not work to keep track of which row I'm on? Just throw one out that would not work. Currency probably would work. It would be a weird one to use because it's going to be 4 digits of precision. It's going to be numeric. So I think that would probably work okay, but definitely not a good one to use. Boolean wouldn't work. True and false value is all we have. We can't say we're on row 300 with a Boolean variable. Other ones that wouldn't work? Byte. So there's an integer one that's just not big enough because the range for byte is 0 to 255. So it's 256 values, but it starts counting at 0. And so that wouldn't work as well. But how about integer? Would integer work for this? Yeah, the range is plus or minus 32,000 roughly, and that would work just fine when we have 3,000. However, anytime I am making a variable that's going to refer to a row, I'm going to use long. Even though in this context, I know that long is more than I need. Right? It's going to use an extra byte. Oh boy, 1 extra byte to do this. The reason that I'm going to do this is that, listen, I'm not quite sure how the data on this sheet are going to change. And if it ends up that we end up needing to iterate across more rows than 32,767, if I use integer for this, all of a sudden it's going to break. And for the meager price of 1 extra byte, I can use, or maybe it's 2 extra bytes. Yeah, it's a 4-byte number. For the meager price of 2 extra bytes, I'm going to use the long data type here, and that's guaranteed to say, I don't care how far you want to go, this variable can handle any row reference that you want to do. And so I'm going to use that as long. Now, I'm going to be interested in just kind of scrolling through all of the IDs, all of the FIPS codes. I don't want to deal with this first row. So I'm going to initialize this variable to start with row number 2. I'm going to start with 2. I mean, it's not really a row number. It's just a number that I'm going to use to refer to the row. And so now let's look at the do loop. We've done the do loop before. Like when we recorded the macro, we used a do loop to make that happen over and over again. But in that case, we were actually moving the active cell from one place to another. And it turns out that when you're trying to make your code run quickly, changing what's happening on the screen is something that's going to slow things down. And so rather than saying we're going to move the active cell down, because when that active cell gets to the bottom of the page, it's going to cause kind of the screen to scroll and have to update. And we would prefer not to have to update the screen. And so rather than work with the active cell with this do loop to figure out when we're done, we're just going to refer to the cell that we're interested in examining using an expression, using a variable and a reference to that particular cell. So let's go ahead and make the same kind of loop, a do loop. So do marks the beginning of the loop, loop marks the ending of the loop. And remember, do just says, when we come back to the top, here's the top. Loop says, go back to the top. I'm going to want to put an exit clause on here. So before, when we did this, it was like do until the active cell's value was a 0-length string. It's going to be something similar to this. I'm going to do until, but now not the active cell. I'm going to have some reference that is going to be able to look at that cell without ever changing which cell is active. And so here I'm going to say do until. Now the worksheet that I'm interested in is called county, right? That's the code name. I can refer to it directly by that name. Now we haven't seen this. This will be coming up, I think, either the next class or the class after that, but it's coming pretty quickly when we're talking about the range object. But let me just kind of introduce this one to you right now, called cells. You're already familiar with like a sheet name dot range, because that's how we recorded some things. But if I'm working with that, I've got the letter to work with, like I've got the column letter to work with. The nice thing about the cells method is that it's going to allow me to talk about the cell I'm interested in, both with the two numeric indices. So anytime I've got an ordered pair where I'm talking about a cell, it's always going to be row first. It's row and then column. So I'm going to give it two numbers here. The row I'm talking about is going to be held in the variable row, and the column I'm interested in is column number 1. So this is going to be a reference to a particular cell depending on what value is in the row variable. The first time through, row is going to be 2. So the first time that we look at this, we're going to be looking at, on our counties worksheet, cell number A2, because the column here is the first column, so that's column A, and then the row is going to be 2. So this is a reference to the cell, and I want to look at the cell's value. I'm going to do until that expression, that cell's value is equal to a 0-length string. Or let me just introduce you to something else. There's a built-in function called isEmpty. Is EMPTY. And if I put a reference to a cell here, I think I want to say dot value is empty active cell. Oh, VALUE. Okay, so that's telling me. So it's a built-in function, part of the VBA language, that will let me know if whatever expression I'm looking at is empty, like if it's a 0-length string. So 0 itself is not empty, but an empty string is. I thought an empty string was empty. I don't use isEmpty very often. I usually just use a 0-length string. Let me go ahead and kind of look down here to see how we get this to work. isEmpty. Let me look at the active cell's value here. I guess it's still going to be false. No, so there, that is telling me that it is empty, interestingly. So it doesn't evaluate to true on an empty string, but it does for a cell. So I think I'm going to use that just to kind of introduce you to something else. I'm going to do until this condition is empty, looking at the value of that particular cell, is going to evaluate to true. So isEmpty will always be true or false. It's a Boolean function, returns true or false. I could get the same thing here if I said is equal to a 0-length string. This would behave the same way. So we're just using the isEmpty just to kind of show you a different way to do it. Is EMPTY. Okay, if I run this now, I've got an endless loop because I haven't done anything to change what the value of row is. So here inside my loop, I'm going to want to tell row to increase. So row equals what it used to be plus 1. And just a good habit, anytime I'm using a do loop, especially a do loop, I'm going to put in the keyword do events. Without the keyword do events, if I accidentally put myself into an endless loop, the VBA interpreter will be so excited to have something to work on, even if it's totally pointless. It will lock up Excel such that I can't tell it to stop. But with the do events in there, if I hit either the stop button or the pause button here, then it will, like once during each iteration of the loop, the interpreter is going to say, hey, is someone trying to get my attention? And if so, it'll kind of let us out. So you can put do events in any loop, but especially when you're beginning, you should put it in every do loop that you make, because do loop, you are having to make the exit condition, and it's really easy to put yourself into an endless loop. What would happen if I put myself into an endless loop and I didn't have do events? I've got to kill Excel. I've got to hit, what is it, Control-Shift-Escape, bring up the, I'm not sure I even can on this computer. Control Alt Delete. Yeah, I can't even show you the options because they're on the wrong screen. All I get is sign out and cancel. That's my only options there. They've got these machines kind of locked down. But I'd have to find some way to kill Excel. I could probably do it by like right clicking here and choosing close all windows. I think it would still respond to that. Yes. Oh yeah, let's do that. Let's just actually TASKMGR. Task Manager has been disabled by my administrator. So I don't know what they think I would do bad with Task Manager here at the podium, but I'm not allowed to do it. Okay. But that's okay because I've got do events in my loop. So I'm not going to worry about that. In fact, let me just go ahead and comment this out. Right, so I've now turned my incrementer into a comment. And if I run this, it's running. And it is, it has already processed that loop millions of times. I mean, it's going to do this very, very fast. Maybe not millions. But because I've got the do events in there, I can hit the pause or the stop, and that will interrupt it. But without that do events, I'd be sunk. I'd have to kill Excel to bring it back. Okay. So here, let me just go ahead and just kind of see that I'm getting what I'm after. So I'll do a debug.print inside this loop. And I'm going to print row so we can see it going up. And I'll go ahead and print the value that is in that first column. So that's going to be the FIPS code. And I'll do also what's in the third column, which is the name of the county. So now when I run this, it should kind of print that information up into my immediate window. Now, it's going to take substantially longer to run through this loop if I'm printing it out, because it takes time to print out to the immediate window. So, this to me seems like it's really kind of going through this kind of slowly, and that's because the immediate window is it's not especially fast to write out the immediate window, but it's like 3,000. Was it 3,200 something? Yeah. So you kind of made it through all of them. That's the point. And a loop that would kind of go through that. Now, we didn't change the active cell. We just wrote an expression that looked at two different cells to decide when it was ready to stop working through the loop. Questions here? There's two more things I want to show you about the do loop, maybe three. The first one is that I can put the exit condition either at the top or I can put it at the bottom. I can't put it in both places, but I can put it either at the top or the bottom. And so now, do this. Let me change this to row starts at 1. It's just going to start with the header. So if I ran that, it would do the same thing. I'm going to break into it. But what is the difference between putting the exit condition down here at the bottom of the loop, then putting it at the top of the loop? Any thoughts? Yeah.
Typically, until hit the loop and then go to the do until, and then if the condition is met, then it'll go down underneath the loop. But if it just goes into the loop and the condition is met, then it'll just keep going instead of jumping back up to the top of the loop.
I'm not sure I totally understood what you were saying. I think you might have been right on. Let me say it back, and you can tell me if this is what you said. So the difference is, where does it actually look to see if it should exit the loop? And if it's at the bottom, then it doesn't check to see if it should exit the loop at the very top. So when the exit condition is at the bottom, I am guaranteed to run the code that is inside the loop once, because it doesn't even look to see if it should get out of the loop until it's run the code in the loop. But if it's at the top, it's possible that I won't come into this loop because I'm going to continue to loop here until this condition is true. And if that condition is true, when I come into the loop, when I first start here, it's going to say condition's already met. We're not running the loop at all. So it's tempting to think, oh, so it's going to run at least one more time if you put it at the top, but that's not true. The only difference is it guaranteed to run the first time? Because after the first time through, where what happens between the loop and the do? Like we hit the loop and the very next thing is back up to the do. There's nothing else that's going on between it. And so the only difference between where I put that exit condition is, am I guaranteed to run the code once? So in this situation, I'm starting here at number 1. Let me just kind of show you. Let me come over here to counties, come back up to the top. I'm just going to delete FIPS code here. So at this point, the condition is met right now. So I'm starting at 1 and it's checking to see if loop. Let me go ahead and put this at the top. It's going to say, hey, we're going to continue to do this until the cell in column 1 on row, whatever row we're on, until that's empty. So this code inside the loop is not going to run. So it looks like it's running. I ran the wrong one. Thank you. Oh, yeah. Let me comment this out because I really don't want this running at all. So yeah, so what happened was it jumped over this loop and it got down here and it executed that. So let me come back to counties. I'm looking at doesn't matter which my active cell is because I'm referred to it there. And let's run that code. And it just runs very quickly. We don't even see it do anything. Now, but if we do this, put it at the bottom, it's not going to check until we've already run this code once. And you'll notice that what this does is this changes the row I'm looking at. And so by the time we hit this, I won't be looking at row 1. I'll be looking at row 2, which isn't empty. And so that's going to run on. It'll run through the whole thing. So placing the exit condition at the top or the bottom is, it's kind of an important consideration depending on what you want the loop to do. Questions on the until clause? The until clause says this loop is going to execute until the condition is true, or as long as it's false. As long as that condition is false, we'll continue to run. So they've given us some, kind of a nice, interesting option here is instead of saying until, we can say while. And so now this is going to execute while the condition is true. So as long as the condition is true, it's going to execute. When I say while, it means as long as the condition is true, we continue executing. When I say until, it's as long as the condition is false, we continue executing. So that's just the distinction. It's syntactic sugar because, of course, this would be exactly the same as, should say this. So if I say not, whatever this condition is, if I reverse this with a not statement, then that's exactly the same as saying until. So it's just to make the code easier to read. And again, this is part of the philosophy behind Visual Basic is that they've added like some additional syntax in here that doesn't give us any additional functionality. We could totally get by with what we had, but it makes the code easier to read to have an until clause versus a while clause. There is one more way to get out of this loop, and that is I'm going to leave this as an endless loop. And I'm going to put another statement in here that just says, if that condition is true, then exit do. So all of the loops, well, the 3 main loops that we have for VBA, you can exit out of them kind of before the loop has run its normal course, just by calling the exit do statement. So exit do for this one, there's exit for the 2 kinds of for loops that we're going to see. So in fact, so we'll see that I'm going to start this now at like 3,000, so it doesn't take so long to get through. But we'll see that will run through and it will still exit when we get to the end. But it's exiting now because we are conditionally executing this statement that says, get me out of the loop. And so exit do lets you jump out of the loop. In VBA, there is no way, I'm pretty sure this is true. There's no way to tell it to go, hey, at this point, go back up to start to the top of the loop and iterate again. That's not built into the structure of loops. Like some languages have a continue statement that will say, hey, go back and start the next iteration at this point. That's not available in VBA. Okay, I think that's everything about the do loop. Any questions on the do loop? So let's go ahead and kind of put this back the way I think is the healthiest way for it to be. So I'm going to make this an until clause. Do until that's empty. And then I'm just going to leave, kind of while I'm debugging here, I'm going to leave the exit do in here. So what does this do? By just putting this as an exit do on a line by itself, what does that do for this loop? So how many print statements am I going to get when I run this now? Yeah, just one. Because it's saying, listen, you've got the whole loop set up here, but you're telling me to get out of it. You know, right here, like run through the code once and get out. This is a really common thing while I'm writing the code. Listen, I've got my loop all set up, but I don't want this thing to run 3,000 times. You know, while I'm working on this, I want it to run once. And so I may go ahead and put the import county data now back in here above the exit do so that when I run this code, it's going to run my import county data. Oh. What's that? I do want this in the loop. That's the whole point here. Well, because what this loop is going to do is it is going to go and pull in all of the unemployment data for every county in the data set. That's what we're after. Now, I really don't want to try that in class because I don't think that in the rest of the class, it could get all 3,000 of them. Like during class, it would just take longer. And so, but now instead of having the county hard coded, what do I put here? Yeah, that same expression that I'm looking at here. So here I'm just saying, hey, we're starting on row number 1 or row number 2. Go ahead and go import the county data for that. Now, this is actually going to insert a brand new sheet each time. So I've got gov county, gov county, gov county. So we probably should, after we're done processing that, we probably should go ahead and do something to kind of get rid of that sheet. But now let's go ahead and bring the data in. So what I'd like to do is I would like to take these numbers, and I think we're probably going to, I think this data is going to go back to 2008 for each one of these counties. What I'd like to do is I would like to take these numbers and I'd like to bring them onto my counties sheet. And which one am I interested in? I guess I'm probably interested in maybe the unemployment rate. So I'm going to pull in whatever is in here in column F. And I'd like to put that, you know, kind of starting right here in column D and moving across. So we're going to use a different loop to do that. And so when we run through this, this is going to go ahead and get us to it's going to import our first county data. And now let's see, I've got this worksheet S that is bound onto that worksheet when it gets created. But what happens to this variable when this subprocedure is done running, right? I'm calling import county data. Import county data says, great, you're passing me in a FIPS code. Great, and I'm passing in a FIPS code. And so that's going to be whatever variable, whatever this evaluates to is going to be in the variable called FIPS at this point. Oh, I think this is the first time we've seen passing a value to another subprocedure. So really quickly here, what I've done right here inside these parentheses is I am declaring a variable, right? You recognize that syntax, variable name as some data type. The variable name is FIPS as a string. But when I declare that variable inside these parentheses, it gets its value when I make the call to the subprocedure. So here I'm calling the subprocedure and I am passing it whatever is in the value property of the cell I'm currently looking at based on which row I'm on. And that value, the first time through, it'll be 1000, 1000, will now be what's inside the FIPS variable. So when I use the FIPS variable here in this expression, it's going to be whatever value I'm currently working on. So so looking at this, declaring a variable inside these parentheses, when I do that, that variable is called a parameter, but it is a variable and it's declared with the same syntax. Just show me how comfortable you are with that idea of passing a value to the parameters. 5, 5, 5. A bunch of you are not voting because you're checking your email or you're afraid to say that it's like 2. What? So everyone who's voting says you're comfortable with it. Okay, so we've got some that are saying a little bit lower. So, and this is one of the really basic things about programming is this idea to say, listen, I've got some procedure here that's a general procedure, right? This goes and it fetches a particular web page, and I'm going to do this exactly the same hundreds of times, thousands of times with one small difference. And what's the difference that I'm doing here? The difference is that I want to pick up the information for a different county each time I run it. So the idea here is that I'm going to write a sub procedure that does all of this, but the part that's different is going to be controlled by what value I assign to this variable. So when I say, listen, I want to run import county data, and I'm telling you what value I need to be different for this run, different from the last run. And so this is going to evaluate to whatever's in this cell the first time through, the next time through it'll be this one, the next time through it'll be this one. And all we're doing is we're saying, take that value, send it down to this variable, and then when I refer to this variable in the code, and I'm doing that by integrating that into the URL where I'm going to fetch the data, it's going to bring that in. So if you're still not comfortable with this, I think kind of practicing and kind of seeing this a little bit is going to help as we go along. Okay. But the point is, here I am declaring a variable. S is a worksheet. It's an object variable. It's allowed to bind onto any kind of worksheet. And we're using that to figure out where we should put our data. But what happens to this variable when I get to the end sub? Right? I'm calling it right here. And when I launch this import county data says, hey, we're starting up here. Allocate the memory for this variable. So it says allocates that memory. And the question is, what happens when I get down here? Now, you may have a separate question, but go ahead. Okay, go ahead and ask the question. Yeah, so the question is there a way to run these individually? And yes, yeah, in fact, in no case do I ever run a whole module. Whenever I run, I am running a sub procedure. And so when I'm clicking the play button here to run my code, it is running whichever one has the insertion point in it. So my cursor's down here, so when I run, it runs this sub procedure. So how did it know what this is? And that is that the whole module gets, when I say run, the whole module is parsed. And exactly when does it get loaded? So in terms of the order, when does this part get loaded into memory? I'm not positive. So I'm not sure exactly when that happens, but when we make the call to it here, that's when it says, hey, I got to understand what that person's trying to do. What could this be? Is this a built-in function? No built-in function. It's not a variable. And it goes, oh, it's another defined sub-procedure here. And so I think actually at that point is when this sub-procedure gets loaded into memory so that it can be executed. It's a little different here than other environments that you may be familiar with because VBA is interpreted, meaning that we don't go through a process where this whole thing gets compiled into machine code. It kind of goes statement at a time. Question?
Yes, so you've defined the import county data as a sub procedure. What would be the difference if you had defined it as a function?
So it's kind of a good question. We haven't talked about functions yet. So in fact, the right lingo to say in VBA is, yeah, and you got this one right. I've defined this as a sub procedure. What would be the difference if I defined it instead as a function procedure? So it's actually called a function procedure when I create it in VBA. And function procedures and sub procedures are identical to each other. The only difference is a function procedure sends back a value to where it was called from when it's called. I'm not ready to teach that to everyone. yet. So we're going to have a whole day coming up very quickly when we talk about creating our own function procedures. And we'll talk about that in detail, but that's the difference. Okay. The point that I want to point out here is that I'm declaring this variable here that gets allocated when this subprocedure runs, but that variable is released. The memory for that variable is released back to the operating system when I hit the end sub. So I cannot rely on this variable out here to be able to figure out which sheet we're on. And so what I want to do is I want to be able to get the information for the sheet that was just imported, and I want to write it over here to our county sheet. I'm going to take the unemployment percent and I'm going to write it right out across here, right? Because we've got like monthly data, don't we? Yeah, unemployment rate for January of 2008, February of 2008, and so forth. But what I want to do is I want to take this data and I want to put it going right across here. To do that, I'm going to want to get a reference to the right worksheet to tell it which worksheet I'm pulling the data from. Now, I know that my import county data is going to put that worksheet at the very end of my list of worksheets. And so let's just go ahead and use that same expression to get a reference to that sheet. So after we say import county data, actually, it's going to create it, and so it is going to be the active worksheet at that point. So we'll just rely on it being the active sheet. I think that'll simplify our code rather than trying to refer to it this way. Okay, so let's go ahead and pull that data in. And for this, I'm going to use the for loop. And so I know that we're going to be bringing in fact, our data is going to be here on rows 8 through 182. And that's going to be the same each time we call this page. We've got it 3 times here. Is that true? Starts on 8, ends on 182. This one, I think they're all the same, so it's probably not a very good measure because it's all the same county so far. But anytime I'm saying, listen, I've got to move an integer across a range, that is such a common thing to do in programming that they built a loop that's specific for doing that. And so after we've imported the data, what I want to do is iterate across all of those rows of data that just came in. And so for that, I'm going to use the for loop. Now, the for loop is going to have what's referred to as a control variable. Here, I'm using a variable. I'm creating a variable for my do loop to be able to tell what I want to get out. That's fine. In fact, I want to move my do events here to the bottom of the loop. So let's put this down after the exit do. But there could be other things that lets me out of this do loop rather than counting an integer that we're doing here, right? It could be that we're deleting our sheets until the total number of sheets we have in the workbook is just 1. Could be a different way to get us out of the loop, some different condition to look at. But the for loop says you've got to have a numeric variable that you're going to take across a range. So let me go ahead and declare another variable up here. And I'm going to call this, I'll call it data row. So this is, where my data came in. And again, this is a row variable, so I'll do as long. And now my for loop is actually going to automatically change the value in this control variable. So I will say for the name of the variable that I'm trying to manipulate with this for loop, I'm going to give it a starting value. So I'm going to say that variable is going to equal something to start. And was it row 8? Yes, it's going to start on row 8. So for data row equals 8, the starting value. And then I will say 2, and then I'll put the ending value here. And I want that to be 182. So what this will do, and next is how I mark the end of the for loop. What that will do is it will iterate each time as it moves the value in the data row variable across that range. So the first time through this loop, data row is going to be 8. The next time through the loop, data row will be 9. The next time through the loop, it will be 10. And it will continue to do that until it has executed the loop with 182 in my control variable, and then it will exit out. Let me just print this off so we can see it. Debug.print data row. Data underscore row. And just so we're not, I'm gonna make sure I've got one of these sheets active that has the data on it. And I'm gonna comment out my import really quickly. And I'll run this code again. And so we can see that it has printed that across the range 8. There's the first one it printed. And it took that all the way through 82. And the for loop exits automatically when it's taken the data row past the boundary. So every time when I hit next here, it's adding 1 onto that control variable. And as soon as it gets larger than 182, when it hits next, if it's larger than 182, that's what lets me out. Incidentally, we don't have to count by 1. There's optional syntax here. I can say step 1, and that tells it to count by 1, but we could tell it to count by 5s. And so now if I run that, it's actually adding 5 onto the control variable each time. So you can control how much gets added onto it by putting the optional step clause onto it. You can make it count backwards. So instead of going from 8 to 182, I can go from 182 to 8, but now I'm going to have to step -1. So that'll tell it to count backwards. So we're seeing it counting down to 8 now.
Saying 182 to 8 doesn't automatically tell it to go back.
Saying 182 to 8 does not automatically tell it to count backwards. If I take this off and run that again, if I was going to guess at this, it's going to run 1 time. I'm not positive. Let's run it and see what it does. Get onto it here. Yeah, so it printed the 2. No, let's see. That's this one that's printing it. So I think what it's doing is it's saying the upper boundary here is 8. You started at 182. It is already out of bounds. And so it didn't run this loop at all. But if we tell it step -1, then it will. So, oh, you're counting down to this instead of counting up to it. All right. So now what I'd like to do is actually bring the data over. So we've got the loop that's iterating across all those rows. And let's just bring the data over. So let me start off here by printing a reference to the data that I'm actually after. So let's print data row and cells. Now, I haven't told it which worksheet I'm talking about. Like up here, when we referred to cells, we said we're talking about, look at the county sheet and particular cell. I haven't told it which worksheet. So which worksheet will it assume? Yeah, whatever worksheet is currently active. So I'm going to make sure that I've got this sheet active here when I'm running it. That's one of my sheets that has data on it. So I'm going to say which row am I after? It's my data row variable. Which column am I after? I'm just after the %. And so that's column number F. Now, I could say A, B, C, D, E, F. I could say 6 here. But alternatively, this cells method will take a string argument here as a column letter. And so that will let me tell it a letter here for the column or the number for the column. It's my choice. So now when I run this, it should print off those percentages. Let's see, get that as the 1. And so 2.9% is the one that we've got over here on row 8. And yeah, that's the right one. 0.9. All right, so now I just want to write this over to the other sheet. So when I look at the first one, I don't mind putting them in reverse chronological order. So I'm going to put the newest data right here in column D. But I've already got my row here. Let me just create another column or another variable called call, dim col, as, and this one I am going to make an integer because how many columns do I have? Here's my last column, xfd. Let me just find out what the column of my active cell is. So it's 16,384 columns on the worksheet. How big does integer go? It goes 32,000. So there's, integer is big enough to handle any reference to a column. So I'm gonna go ahead and leave that as integer, save myself a couple of bytes of RAM. Okay, so now let's keep track of this. So I'm still gonna leave this printing off, but I'm gonna say on my county sheet, and I'm gonna look at the cells. Now, which cell do I wanna write to? The one I'm currently looking at, so cells row. The column I'm gonna write to is call. I haven't set up what that is yet. I'm gonna set the value of that, and that is gonna be equal to this value that I was printing out. I'll just copy, oops, that should say dot value on the end. I didn't say dot value, but it printed the value. And that's, again, that's the Visual Basic Interpreter saying, you can't print the whole object. You must have just forgot to put dot value, because that's the most common thing that people want to know about the cell is its value. So I'm going to read off of my active sheet, whichever row data row is currently looking at, column F. I'm going to write to whatever call is. So I want this data to start in column D, so that's the fourth column. So before I come into this loop, I'm going to say call equals 4. And so now it's going to write to the fourth column, and then inside this loop, I'm going to increment call. So call equals what it used to be plus 1. So for the whole time through this loop, we're going to have the same value for row, because we're not changing row inside the loop, but we are changing call inside the loop. So the first time we hit this statement, it's going to write to column number 4. The next time through, it's going to write to column number 5, and so forth. So it should take all of those values and write them right across here for the county that we're on. So I'm going to go ahead and run this. And again, I'm not importing the data, so I better make sure I'm on one of my data sheets. That import data would activate that sheet. So yeah, so what this is going to do is it's going to start with 182, and it's going to, that's the most recent data. And it's going to put the most recent data then here. So it's okay. I would be fine to put the oldest data here or the most recent data here. Either way would be fine. I'm going to just kind of leave it the way it is. So I'll get one of these sheets active. I'll run this, and it should put all those numbers in. Come back to look at my counties. Now it's put these all in. I'm not sure I like having the projected number. Maybe I want the real number, because that is a kind of a substantial projection. I mean, look at that. That is a 1% month over month projected change. And we really haven't seen anything in the numbers that would suggest it's going to be that much of a jump. I bet that projection's high, but I don't know. Some pretty smart economists probably made that projection. They got more data than I do. Question?
It said on the other sheet that they're preliminary. So
oh, it's not projected, it's preliminary. Ah, okay, thank you. Good to figure out what the P means, preliminary. Should we get rid of the, should we ignore the one that's preliminary, or should we get rid of the %P that's on it? Ignoring it's easy, because that's going to be the last, it's just the last one. So instead of starting at 182, we'll start at 181. And that will just start our data. Oh, whoops, I was on that, I had the wrong sheet active. So it actually read where that data would have been, but there was nothing there. So let me come over here to activate this sheet, run it again. And so now we're not using that. It wasn't projected. It wasn't provisional. What was it? What did it stand for? Preliminary. So we now no longer have the preliminary number on. So if we were to take out our exit due, this thing would run. It would bring in all of that data. It would take a while. It's going to make a call for each page, bring that data in, and then lay it in. Questions? All right, let's do this. Let's look at a different loop. And I introduced you to the for each loop last time. You might remember we used the for each loop to kind of try to delete all of the worksheets. We said, for each sheet in the worksheets collection, and then we tried to delete it. Worked out okay until we got to the very last one, which caused an error. So what the for each loop allows us to do is to iterate across all of the objects in a collection. It's another thing that we do so often that they made a specific syntax in the loop. By the way, could I have used a do loop to get this data? Yeah, I just would have had to control the variable myself. But because I'm moving a variable across a range, there's kind of a built-in style for that. So let me do this. I'm going to take this, I'm just going to comment this whole block of code. And by the way, in case you're interested in being able to comment out a whole block at once, let me show you how to get that tool showing here in your editor. I'm going to come up here to View and come down to Toolbars. And there's an Edit toolbar that has that tool on it. So I'll click on Edit. That should have brought up a toolbar. Where is it? Oh, it's way over here. No, that's the magnifier. Do you see it somewhere? Oh, there it is. Thank you. Yeah. And I'm just going to drag this up so it docks right next to my other toolbar there. And then these two buttons allow me to comment a whole block of code and uncomment a block of code. There is no, in VBA, there is no multi-line comment syntax. So I can't say from here to here is all a comment. So I've got to do it with a single quote. So that tool can be handy. Now, what I'd like to do here is I would like to accomplish the same thing, but using a different kind of loop. Oh, by the way, there is an exit for as well, EXIT for. So just the same way I can exit out of a do, I can exit out of a for. So just it's exit for instead of exit do. Okay, so now let me go ahead and do this. I'm going to declare another variable up here. I'm going to call it RNG as a range object. And so what I'd like to do is I would like to now just to introduce us to another use of that for each loop. Instead of iterating across all of the sheets in the collection of worksheets, I'm going to iterate across all of the cells in a range. I'm going to start off by identifying the range that I want to iterate across. And so I now have a range variable that I will use to do that. So I'm going to put it right here kind of close to the column 4. And let's set RNG equal to, and now we're going to see how we refer to a multi-cell range. And I do that by saying range. Now you're familiar with the range method because we would come in here and we would say that we're talking about range A1. But now what I'm going to do is I'm going to put 2 references in here. And now instead of referring to a single cell range, it's going to refer to a multi-cell range. Or you know what? We're gonna see that syntax later. Because we know what the range is going to be, I can do it just with like regular cell reference notation. So the range I'm after is going to be F8 to F181. So I'll set that range here to F8 colon F181. And we typically show column references in uppercase, although they would work just fine in lowercase. Which worksheet will this be on? Whichever one is active when this statement executes. Okay, so now range is going to be a multi-cell range. And so now I can iterate across all the cells of that. So I needed to have this data row variable for working the for next loop. I'm going to go ahead and leave it declared. But I need a different kind of control variable for the for each loop. And so I will just call it cell as a range. That might seem a little strange because you might think cell is a reserved word, but it is not a reserved word. So now, after I've set the range to be this, I'm now going to say for each cell in RNG. Next. So what's going to happen here is that my object variable, cell, is going to get bound on to the first cell in this range, the first time through the loop. The next time through, cell is going to point at, and that'll be F8. The next time through, it'll be F9. The next time through, it'll be referring to F10. So cell is going to be a different cell each time. So now I'm just going to go ahead and kind of copy my line out here that's keeping track of where I'm writing to, and say that's going to be cell.value. I don't have to have this more complex way to use an integer to refer to it, because the control variable is going to be a reference to a cell itself. This is a little confusing because this expression cell.value is going to be a different, it's going to be referring to a different value each time it runs. And to understand that, I've got to realize, oh, that's because this is the control variable of this for each loop. And a for each loop says, I'm going to iterate over all of the elements in the collection, all the objects that are in this collection. So in this case, it's all of the cells in the given range. I'm also going to need to increment my column for each cell column. Yeah, because column is, it's keeping track of where I'm writing my data out to. So column is still going to get set to 4, kind of coming into this. We'll increment it as we go because that's what's telling us where we're writing it out to. And that should bring in the data. Now, what order is it going to bring it in? What order do you think this is going to go in? The cell that's highest on the page or the cell that's lowest? It's going to go from the top and go down. So instead of bringing in the most recent data first, it's going to bring in the oldest data first because of the way the data is organized. And incidentally, this is just one column, right? It's one cell. This column is one cell wide. If this column were 3 cells wide, it would actually go first cell in the first column, first cell in the second column first. It would go across the cells first instead of going down and over. Just that's the default way that it iterates. I say default as if you can change that. You can't change that. That's the way it iterates across a range. Okay, I think that's going to work. Let's give it a shot. Let me go ahead and pull the data off my sheet here and run this again. Oh, darn it, I'm on the wrong. Gotta have the right sheet activated and run it again. And so it is, and there's my 2.9s that are, happening in 2008. So again, when I have a need to iterate over across all the elements in the collection, the for each loop was made for that specifically. So let me go ahead and do this. I'm going to go ahead and bring in a few of these. So instead of exit do here, I'm going to say if row is greater than, why don't we say 8, then exit do. So now instead of just exiting after one time through the loop, it's going to go a few times looking at how we've incremented row, and it's going to bring in that data. So we should be able to see that data coming in. We won't really see it coming in because it's going to be bringing in a new sheet each time. But when I'm done, let's just go ahead and do it. It's going to add some sheets, what we'd have to deal with because we can't fit 3,000 sheets. By the way, how many sheets can you have in a workbook? You know? It's less than 3,000. I think it's 255 or 256. I think that's the limit for the number of sheets you can have in a workbook. So we'll have to do something to control, kind of when we're done reading that data off, probably get rid of that worksheet. But let's run these and then maybe we'll add that for our last example. So I'm going to remove the comment on the import. So now we're going to start with row 2. We're going to pull the data in. We're going to write it across. And we should do it until we've finished row 8. Probably finish row 9 as well. So we can see it's still running here. We're doing FIPS code 1000. And now we're on to 1001, 1003. And we should get, maybe I did too many. It's getting boring to watch. Looks like we're on row 6, so we don't have that many more to go. 7. I think we're going to get 8 and we're going to get 9 because we're not going to exit until we're larger than 8. And that should let us out. Come back here and look at the counties, and we've brought in that data. So if we were trying to collect this data, let this thing run, go get a ham sandwich, and might be done by the time you got back. 3,000. It's taken. It took a few seconds each time, so it's going to take a while. Okay, last thing then on this example is just going to be to delete that sheet. So let's see, when am I actually done working with that sheet? It's when I'm done with this loop. So I know my sheet is the active sheet. So at this point, I should just be able to say active sheet dot delete. But let me do this first. I'm going to say before this loop starts, I'm going to come up here and say, don't nag the user for deleting that sheet. That is application dot display alerts equals false. Don't display the alert, just do it. And here I'll say active sheet dot delete. I'm going to delete all my current data sheets here. And I'm not going to do 8, I'll do 4. Run this again. And now we're not going to see it pull the new data in because it's writing over the existing data. But we will see that it's not, in fact, you can see that now. When we see the counties, we see the county sheet here, and we're not getting the other sheets brought in. We won't know for sure that it's updated the screen until the code stops. And we can see that we're no longer kind of stacking up those sheets. So this thing should now run and let it pull in all that data. Those are the 3 basic kind of loops: the do loop, the for loop, and the for each loop. Questions? Okay, thanks for coming. Do something exciting for Constitution Day this Saturday, and I will see you next week. Yeah, you're all Constitution Day. Class dismissed. Yes. I did. Yeah, because it's only deleting the most recent one.